Imagine Albert Einstein looking at Mars through a telescope, not as a dream, not as a red adventure waiting for human footprints, but as a problem of physics, a cold planet, a thin atmosphere, no global magnetic shield, dead soil filled with sharp dust, weak gravity pulling on a body that was built for Earth. And then Einstein asks the question most people avoid: what if Mars is not the next home for humans? What if it is a trap? Because going to Mars is not just about distance. It is not like crossing an ocean. It is not like climbing a mountain. Mars is a different system, and the moment a human body enters that system, the fight begins. The dust does not behave like Earth dust. On Earth, water and wind smooth particles over time. But on Mars, dust can be sharp, dry, electrostatic, and difficult to remove. It can stick to suits, cover solar panels, enter machines, and threaten the equipment that astronauts would depend on to survive. Then comes radiation. Earth protects us with a magnetic field and a thick atmosphere. Mars does not give the same protection. Outside Earth's shield, energetic particles from the sun and deep space can pass through spacecraft and human tissue, damaging cells in ways the body may not fully repair. And even if humans survive the dust, even if they survive the radiation, Mars has one more silent weapon: gravity. Mars has only about 38% of Earth's gravity. At first, that sounds comfortable. Lighter steps, easier movement, less weight. But biology is not fooled. Your heart, bones, muscles, blood vessels, and balance system were shaped by Earth's gravity. Remove most of that load for long enough, and the body begins to adapt. The heart can weaken, bones can lose density, muscles can shrink. The body may slowly become less Earth human and more Mars adapted. And that is where the nightmare begins. Because the real question is not only, can we reach Mars? The real question is, after Mars changes us, can we ever truly come back home? This is the terrifying physics behind the red planet, a journey that looks like exploration from the outside, but may become a one-way transformation from the inside. To understand why Mars may be far more dangerous than it looks, we need to stop thinking like tourists and start thinking like Einstein. A tourist sees distance, a physicist sees systems. A tourist says, Mars is the next planet. We just need a bigger rocket. But Einstein would ask, what forces are waiting there? What environment will the human body enter? And what will that environment do to the machines and biology we depend on? Because Mars is not simply far away. Mars is hostile in a quiet, patient, physical way. It does not need monsters. It does not need storms like in science fiction. It only needs dust, radiation, and gravity. Let us begin with the first enemy: Martian dust. On Earth, dust has history. It has been softened by water, rain, rivers, oceans, plants, humidity, and weather. A grain of sand on Earth has usually been rolled, washed, rubbed, and broken down over long periods of time. Its edges become smoother. Its surface becomes less aggressive. Earth makes dust that has been trained by life and water. Mars does not. Mars is dry. Mars is cold. Mars has no active oceans washing the rocks, no rainfall softening the soil, no thick atmosphere protecting the surface the way Earth does. For billions of years, Martian rock has been smashed by impacts, cracked by temperature changes, and broken into fine particles without the same smoothing process we see on Earth. So Martian dust is not ordinary dirt. It can be sharp, it can be abrasive, it can behave like tiny fragments of broken mineral glass. And because Mars is extremely dry, those particles can also become electrostatically charged. That means they can cling to surfaces. They can stick to suits, lenses, solar panels, seals, tools, and machinery. On Earth, if dust gets on something, you wipe it away. On Mars, wiping may not be enough. The dust may cling, it may scratch, it may grind. It may enter tiny gaps where machines need precision. And here is where the danger becomes serious. A human mission to Mars cannot depend only on what it carries from Earth. That would be too heavy. Fuel is heavy, water is heavy, oxygen is heavy. Every kilogram launched from Earth costs energy, space, and engineering complexity. So long-term Mars plans often depend on using local resources. This idea is called in situ resource utilization. In simple words, use what Mars gives you. Take carbon dioxide from the Martian atmosphere. Extract water ice from the ground. Use chemical processes to make oxygen and possibly rocket fuel. This sounds brilliant, and it is brilliant engineering, but it depends on machines working reliably in one of the harshest environments humans have ever entered. Pumps must pump, compressors must compress, solar panels must collect sunlight, seals must hold pressure, airlocks must close perfectly, drills must dig, filters must filter, bearings must spin, valves must open and close again and again. Now place all of that inside an environment filled with fine, sharp electrostatic dust. The dust gets on solar panels and reduces power. It gets into joints and moving parts. It can scratch surfaces. It can threaten seals. It can enter spaces where even a small leak becomes dangerous. And if your fuel-making system fails, the problem is not inconvenience. The problem is survival, because the return trip may depend on fuel made on Mars. A mission can be designed with backups, protections, cleaning systems, and redundancy. So we should not exaggerate and say dust makes Mars impossible by itself. But we should also not pretend it is just dirt. Martian dust is a system-level threat. It attacks energy. It attacks mobility. It attacks machinery. It attacks spacesuits. It attacks airlocks. It attacks the very technology needed to keep humans alive. And Einstein would notice something important here. The danger is not dramatic. It is cumulative. One scratch may not kill a mission. One dirty panel may not end everything. One damaged seal may be repaired. But Mars does not stop. Day after day, dust settles, dust clings, dust enters, dust wears things down. A human body can rest, a machine can be switched off, but entropy does not sleep. Disorder increases, friction wins slowly, systems decay. And on Earth, we fight that decay with massive support. Factories, replacement parts, repair teams, hospitals, supply chains, clean rooms, oceans of water, and a thick atmosphere. On Mars, every repair is happening inside a desert vacuum world millions of kilometers from home. That is the first trap, the machine trap. But the second trap is worse because it does not attack the rocket. It attacks the astronaut, radiation. On Earth, we live inside invisible protection. Above us is a thick atmosphere. Around us is Earth's magnetic field. Together, they shield the surface from much of the dangerous particle radiation coming from the sun and deep space. We rarely think about this because we are born inside the shield. It is like a fish not noticing water. But leave Earth, and you leave that protection behind. In deep space, astronauts are exposed to energetic particles from solar events and galactic cosmic rays. These particles can travel extremely fast and carry enough energy to damage atoms and molecules inside the body. The most frightening part is that radiation does not need to make a person feel pain immediately. It works at the level of cells, at the level of DNA, at the level of chemical bonds. Your body is made of molecules arranged in careful patterns. DNA holds instructions, proteins perform repairs, cells divide, communicate, and maintain order. High-energy radiation can disturb that order. It can break chemical bonds. It can damage DNA. It can create cellular stress. The body has repair systems, and those systems are remarkable. Every day on Earth, your cells repair damage. They correct mistakes. They remove broken pieces. They rebuild. But deep space radiation creates a different challenge. It is not one injury. It is long exposure. A Mars mission could involve months traveling there, time on the surface, and months returning. That means the body is not dealing with one brief radiation event. It is dealing with ongoing risk. And if a major solar particle event happens at the wrong time, the danger can rise sharply. This is why spacecraft shielding, mission timing, storm shelters, and radiation monitoring are so important. But shielding is not simple. On Earth, our atmosphere gives us kilometers of protection. A spacecraft cannot carry kilometers of air. Every shield adds mass. Every kilogram makes launch harder. And some forms of high-energy radiation are very difficult to block completely. In some cases, when heavy particles hit shielding material, they can create secondary particles, which adds another layer of complexity. So the astronaut is not just traveling through space. The astronaut is traveling through a particle storm that biology was never designed to face for long periods. The risks may include increased cancer risk, damage to the central nervous system, cardiovascular concerns, and possible effects on organs such as the kidneys. We must say this carefully. A Mars astronaut does not instantly fall apart. NASA and other space agencies study these risks seriously, and future missions would use protective planning. But the danger is real enough that it cannot be treated like a small technical problem. Because radiation is not only an engineering issue, it is a biological issue. And biology has limits. Imagine trying to pilot, repair, calculate, land, drill, build, and survive, while your body is under constant stress from isolation, low gravity, poor sleep, radiation exposure, and the knowledge that Earth is only a bright dot in the sky. This is not like a difficult camping trip. This is a human nervous system, immune system, skeleton, muscles, and organs being asked to operate in an environment outside the conditions that shape them. Einstein once showed that space and time are not separate. For Mars travel, we must understand another connection. The astronaut and Earth are not separate. A human being is not an independent machine that can simply be placed anywhere. A human being is Earth biology, built under Earth gravity, protected by Earth's atmosphere, shielded by Earth's magnetic field, fed by Earth's biosphere, balanced by Earth's day and night. To remove the human from Earth is not just relocation, it is extraction from the system that made the human possible. And Mars does not gently accept that body. Mars begins changing it. First, the machines face dust, then the cells face radiation. And after that comes the quietest danger of all. Gravity. Not too much gravity, too little. Mars gravity feels like a gift at first. Only 38% of Earth gravity. You would weigh less, move differently, lift more, jump higher. It sounds fun. But the human body hears a different message. It hears, we do not need as much muscle. We do not need as much bone. We do not need the same heart strength. We do not need the same blood pressure response. And biology is efficient. What it does not need, it starts to remove. That is where Mars becomes more than a destination. It becomes a place that slowly rewrites the body. Gravity is the quiet force that built you. You do not feel it as something special because it has been with you since the first second of your life. Every heartbeat, every step, every breath, every movement of blood through your body has happened under Earth's gravity. Your bones grew because they had to carry weight. Your muscles stayed strong because they had to resist the pull of the ground. Your heart became powerful because it had to push blood upward to your brain. Your balance system learned Earth because Earth was the only world it knew. So when people imagine Mars gravity, they usually imagine freedom. They imagine jumping higher, walking lighter, moving like a superhero. But Einstein would not see only the dream. He would see the equation. Less gravity does not mean no consequence. It means the body receives a new instruction, and that instruction is dangerous. You do not need to be as strong anymore. Mars has only about 38% of Earth's gravity. At first, this sounds comfortable, but biology is extremely practical. It does not keep expensive systems strong if it thinks they are no longer needed. If muscles are not loaded, they shrink. If bones are not stressed, they lose density. If the heart does not have to work as hard against gravity, it can weaken. This is not because the body is failing. It is because the body is adapting. That is the terrifying part. Mars does not only threaten the astronaut. Mars slowly trains the astronaut to become less suited for Earth. And the longer a person stays there, the deeper the question becomes. Are they still preparing to return home? Or are they becoming physically redesigned for a weaker world? This is why the return journey may be the real nightmare. Imagine surviving the launch from Earth. You survive months in deep space. You survive radiation. You land on Mars. You survive the dust. You help build systems. You make fuel. You live under low gravity. Then, after months or years, you finally begin the journey back. For another long period, you are in space again, exposed to microgravity or artificial conditions that are still not Earth normal. Your bones may weaken further. Your muscles may lose more strength. Your heart may lose some of its Earth-trained power. Then your capsule reaches Earth, the planet you dreamed of, the blue sky, the ocean, the air, home. But home does not welcome you gently. Earth pulls with full force. 1G, the gravity your body once handled without thinking now becomes a wall. You try to stand. Blood rushes downward into your legs. Your heart struggles to push enough blood back to your brain. Your balance system is confused. Your muscles are weak. Your bones are fragile. You may collapse before you even take the first step. This is not science fiction. Astronauts returning from long space missions already need recovery time, medical support, and rehabilitation. Their bodies change in space. Mars adds another layer because it is not weightlessness, but it is also not Earth. It is a middle world, strong enough to create a false sense of normal life, weak enough to reshape the body over time. And this creates the deep biological trap. If you stay on Mars long enough to adapt, returning to Earth becomes harder. If you do not adapt, living on Mars becomes harder. Either way, the human body pays. Now connect this to the other traps. Dust damages machines. Radiation damages cells. Low gravity changes the body. Each one is serious alone. But Mars does not send them one at a time. They arrive together. The astronaut is not facing a single enemy. The astronaut is inside a system where every part of the environment is pulling against survival. Dust threatens the equipment needed to make fuel and maintain habitat safety. Radiation threatens the organs, DNA, brain, blood vessels, and long-term health. Low gravity threatens the heart, bones, muscles, and ability to return to Earth. And all of this happens far from hospitals, factories, repair teams, emergency evacuation, and Earth's natural protection. This is why Mars is not simply a destination. Mars is a test of whether human biology can survive outside the planet that created it. And here, Einstein's thinking becomes important. Einstein changed physics by showing that nothing exists in isolation. Space and time are connected. Matter and energy are connected. Gravity and geometry are connected. In the same way, a human being is not separate from Earth. You are not just a mind inside a body standing on a planet. You are part of the planet's system. Your lungs expect Earth's air pressure. Your bones expect Earth's gravity. Your cells expect Earth's radiation protection. Your sleep expects Earth's day-night rhythm. Your blood expects Earth's pull. Your immune system, muscles, hormones, and nervous system have all been shaped by this one world. A human is not just living on Earth. A human is an expression of Earth. Take that body away from Earth for long enough and the universe begins negotiating with it. Mars says, become lighter. Space says, accept radiation. Dust says, let your machines wear down. Distance says, no fast rescue. And physics does not care about ambition. It does not care about flags. It does not care about speeches, timelines, or posters of cities under glass domes. Physics asks only one question: can the system remain stable? That is the real challenge of Mars colonization. Not reaching Mars, not planting a flag, not taking a dramatic first step. The challenge is creating a stable human system on a planet that is not designed for humans. A rocket can take people there, but can biology stay there? Can machines keep working there? Can fuel be made reliably there? Can bodies survive radiation for years? Can children develop normally in low gravity? Can a Mars-adapted human return to Earth safely? These are not small details. These are the foundation. Without them, Mars is not a second home. It is a beautiful red experiment with human bodies inside it. That does not mean exploration should stop. Einstein never feared questions. Science is built on curiosity. We should study Mars. We should send robots. We should send instruments. We should send orbiters, landers, drills, cameras, and laboratories. Robots are perfect explorers for Mars. They do not need bones. They do not get cancer. They do not need oxygen in the same way. They do not panic in isolation. They can sleep through dust storms. They can wake up years later and still send data home. And one day, humans may go too. But we must tell the truth about what that means. A human mission to Mars is not just an adventure. It is a biological gamble, a thermodynamic battle, a fight against dust, radiation, gravity, distance, and time. The danger is not that Mars is evil. Mars is not evil. Mars is indifferent. That is worse. A hostile enemy can be understood emotionally. An indifferent planet simply follows physics. Its dust will scratch because the particles are sharp. Its radiation will damage because the shielding is weak. Its gravity will reshape because biology adapts. Its distance will punish mistakes because help cannot arrive quickly. Mars does not hate humans. It simply does not belong to us. And maybe that is the lesson we need. We often look at Earth as if it is ordinary, but Earth is not ordinary. Earth is a miracle of conditions, a thick atmosphere, a magnetic shield, liquid water, one gravity, a stable biosphere, a sky that burns meteors before they hit us, a field that bends charged particles away, a planet that silently protects us every second of our lives. We dream of escaping Earth, but perhaps we have not fully understood what Earth has been doing for us. Mars teaches humility. It shows us that survival is not automatic. It shows us that life is not just about having a place to stand. Life needs a whole system: air, pressure, temperature, water, gravity, shielding, chemistry, repair, balance. Earth gives all of this freely. Mars gives almost none of it. So the real question is not, can humans reach Mars? Yes, with enough technology, courage, and preparation, humans may reach Mars. The deeper question is, can humans remain human there? Can a body made for Earth live for years on a world that slowly pulls it away from Earth's design? Can someone come back after Mars has changed their bones, heart, cells, and nervous system? That is the haunting possibility. Mars may not trap humans with walls. It may trap them by adaptation, by making return harder the longer they stay, by turning home into the harshest environment of all. Imagine that. You leave Earth to become a Martian explorer. You survive the red planet. You dream of coming home. But when you return, Earth itself becomes too heavy. The planet that made you becomes the planet that crushes you. That is the dark side of Mars nobody likes to put on posters. Not because Mars is impossible, but because Mars is not simple. And if Einstein taught us anything, it is this: reality is not required to match human intuition. Time can bend, space can curve, light can be trapped, and a planet that looks like humanity's next step may turn out to be a one-way transformation. So when you see Mars glowing red in the night sky, do not see only a dream. See a warning, a world that asks for more than rockets, a world that demands we understand dust, radiation, gravity, biology, and the fragile connection between humans and Earth. Because maybe the greatest lesson of Mars is not that we must leave Earth. Maybe the greatest lesson is that we finally understand why Earth is irreplaceable. If this story changed the way you see Mars, subscribe to the channel, because here we explore the universe through Einstein's deepest ideas. And before you go, comment below. What scares you more about Mars? The radiation, the dust, or the possibility that coming back home may be harder than going there?